Greetings to all learners. Today we will start a new chapter, chapter number 3rd of grade 11th physics, motion in a straight line. So let's start the discussion from position. So position according to the coordinate axis, it is defined as the situation where the body is located according to the coordinate system. Second is path. So the distance covered by a body in unit time, that distance or total distance covered by the body is known as path or path length. Third comes the displacement. So displacement of a body is said to be the change in the position of the body, that is displacement. Now here according to this graph or the diagram, we can have all the views of position, path and displacement. In the first diagram you can see that the coordinate position, that is x axis and y axis, and the origin is represented by 0 or O. So here we can see that a car is moving in y axis, there is no displacement in x axis. So this represents motion in a straight line. With the variation in the time, we can have the different position of this body in the position. Now second graph, here you can observe that different waves are there. So these waves represents that the body is covering a particular distance in x and y axis, but when we talk about the shortest or minimum path covered by the body, so here the body moves from one point to another in a straight path, that will be the minimum distance covered, which is known as the displacement. And if the body covers the wave and reaches to the final destination, so this will be the total path covered by the body. So here comes the position, path and displacement explanation. Now let's talk about average velocity and average speed. So with the understanding of average velocity and average speed, we can understand the concept of velocity and speed too. As we know that the distance per unit time is known as speed and displacement per unit time is known as velocity. So here we can understand the concept of average speed and average velocity also. So the ratio of total distance covered by the body and total time covered by it, the ratio of that is known as average speed. And we talk about average velocity, so displacement upon time is the average velocity. So here to explain the condition and the concept of average speed and average velocity, we can solve a question. So a question is given in the slide. A car is moving along a straight line, say OP, in a figure below. So in this figure we can have the different location like O, Q and P. It moves from O to P in 18 seconds. So O to P in 18 seconds means so from 0 coordinate position to 360 coordinate position, which is referred to be in meters. So in this distance is covered in 18 seconds. The body returns from P to Q in 6 seconds. So again the body returned back from P to Q in 6 seconds, and the distance covered by it is from 360 to 240. So you can subtract it from 360 to 220. So coming from 360 to 240, we can subtract it and find that it is 120 meters. So now distance are located from the coordinate system. Now we can find the average velocity and average speed in the coming slide. Now according to the given question, we have to find the average speed and average velocity in two conditions. First condition is the body covers the distance or displacement from O to P. So we will find distance and displacement both. So as the body is moving in the straight path, so distance and displacement will be the same thing. So from O to P we have already calculated the distance or displacement to be 360 meters. Now time taken in doing that is 18 seconds. So average velocity of the car will be displacement per unit time, that is 360 meter per 18 seconds. So if we solve that, we will get the average velocity of car is 20 meter per second. When we talk about average speed, so distance upon time will be the formula for it. Again we will get the same value, 20 meter per second. Now we will solve the second part of the question. In second part, the body first goes from O to P and then return back in the same path but opposite in direction from P to Q. So for that, the total time taken by it from O to P is 18 and P to Q is 6 seconds. So we will get 24 seconds. Now displacement from P to Q is 240 meters, as we have already calculated when we were discussing about the diagram. So average velocity of the car from P to O will be 240 meters upon 24 seconds, because total time consumed in foregoing and return back is 24 seconds, and to find the velocity we need displacement. So displacement is from initial point to final point, means we have to subtract from final point to initial point, and hence we will get 240 meters. So by applying the formula, we will get average velocity as 10 meter per second. Now again find the total distance so that we can find the average speed. So total distance is 360 plus 120, 360 going from O to P and 120 returning back from P to Q, that is 480 meters. Then average speed will be equal to total distance upon total time. So total distance is 480 and total time is 24 seconds. So hence we will get the answer, that is average speed is 20 meter per second. Now after getting the concept of distance, displacement, path, velocity, speed, now next topic is acceleration. So acceleration is the rate of change of velocity with time. Okay, so according to the formula, we have A is equal to dv upon dt. D represents a small change in velocity in a small duration of time, means instantaneous acceleration is given as dv upon dt. What is the change in velocity in instant of time? Now these are some graphs. So first graph represents the velocity versus time graph. So a body initially starts its journey from V0 and completes its journey by increasing its velocity from V0 to V1 and then V2. So in doing that, it will change the velocity in the given interval of time. So if we find the ratio, we will get the acceleration. Here are some different four graphs are here. All represents that if velocity increases with respect to time, then it is acceleration. If the velocity decreases, as we can see in the figure B, so velocity decreases with respect to time, so this is known as retardation. The similar retardation we can have in two different coordinate position, which is given in figure C and D. Here we can find that the body is moving in the negative y-axis and deaccelerate or retarded in the given time interval. And in figure D, the body retarded from positive y-axis to negative y-axis. Now in this given picture, three cars are there. We can easily understand which car is accelerated higher. So red color is accelerated higher, then blue, then the minimum speed or variation in the speed we can observe in the green car. Now let's talk about kinematic equation of motion. All those expressions, all those difficult conditions of motion can be formulated by three formulas, which is known as kinematic equation of motion. So here we will have all the formulas of kinematic equation with the explanation and derivation too. So let's begin with some nomenclature we are having. So we can say that there are some specific terminology and the symbol for that. First is displacement, which is given as S. Initial velocity is small u, final velocity v, acceleration is small a, time interval t, that is small t. So now with the help of this terminology, we will proceed our experiment. Coming to the first formula of kinematic equation of motion, that is final velocity is equal to initial velocity and the sum of. So this expression, that is v is equal to u plus at, can be derived with the help of this diagram. So this method is known as graphical method. So here we have a velocity versus time graph, in which we can see the shaded area in pink and bluish color. So this area is the outcome of initial velocity. The body is moving with initial velocity as it is marked as initial velocity, initial speed here as u. So the body starts its journey from here and ends, that is at the final velocity with capital V. So this range is given to us and the time interval is from 0 to t, small t. Now the area covered by it is the that we need to find here. Okay, so we will apply the area of the triangle and area of rectangle, and then we will add it to derive the required things. But first thing is acceleration. So here v and u is and time is indicated in this diagram. We can find the acceleration. So as we know that acceleration is change in the speed, so final velocity minus initial velocity. So final velocity is u and v and initial velocity is u. So find the subtraction or difference between them and divide it by time. So acceleration will be equal to change in velocity upon time. If we have this expression, now we can cross multiply it and then we will find the value of the expression, that is at is equal to v minus u. Now v can be calculated as at plus u. So now this expression v is equal to u plus at can be. Now let's derive the second expression of kinematic equation of motion, that is displacement is equal to sum of the product of initial velocity and time and half of the acceleration and square of the time. So here we have the graph again, and with the help of this graph we can find the area of the graph, because the product which we want is the product of the quantity which is given in x-axis and y-axis. So it can be obtained by calculating the area. So to find the area, this section, that is trapezium, is converted into two sections, that is rectangle and triangle. So first find the area of this rectangle. So this rectangle will be equal to product of initial velocity and time, that is ut, given in the diagram, and for the triangle it is half at square, half into base into height. So we will find the sum of it and then we will get the displacement. So displacement will be equal to ut plus half at square. So this will be the expression of displacement with the help of this diagram. Now let's talk about the third expression of kinematic equation of motion, that is v square is equal to u square plus 2as. Now in deriving that, it is also we can have the same diagram in the previous slide which we have seen. We have to find the displacement, but here what is required is the expression should be independent of time. So you will find that there is no expression of time in the equation. So what we will do, we will first try to find the value of t, that is v minus u upon a, from the first expression. Now we will apply this t in the expression which we have calculated or derived in the previous slide. Now if we put in the expression of displacement the new value, which is we will apply the value of t, then we will get v plus u upon 2 into v minus u upon a. So we will multiply it according to the identity a plus b into a minus b. So it is a square minus b square. Similarly we will get b square minus u square upon 2a. Now if we transposition of the expression, we will have v square is equal to u square plus 2as. Now we are at the last of this chapter, that is relative velocity. Relative velocity refers to the velocity which is related to other velocity. If we consider the definition or statement of that, relative velocity is defined as the velocity of object B in the rest frame of another object A. Now here we can have the formula for relative velocity. So if two bodies are in motion, or we are referring two bodies, maybe one is at rest, maybe one is at motion, in any condition we can have relative velocity between two bodies if they are moving in the same direction. In that condition, relative velocity of 1 with respect to 2 will be given as v1 minus v2. Similarly, if we find the relative velocity of object 2 with respect to 1, then we will subtract the velocity of 2 by velocity of 1, velocity of body 1. So this is the way by which we write the relative velocity. Now let's have the discussion to understand the concept of relative velocity. So here in this picture you can find that two bodies are moving and you are observing as the rest body. So in that condition, if you observe both the bodies, you can easily find that what is the difference in the velocity of both the bodies. The body which is a balloon is moving with higher velocity than a body which is on the boat. Now if you are at the balloon or if you are at the boat, if you find the relative velocity between each other, then you will have another assumption. You may find if actually if you are observing at rest and observing the velocity of balloon be 20 meter per second and velocity of boat is 10 meter per second, so this is your assumptions when you are at rest. But if you are at the balloon, you can think that the boat is coming at a velocity of only 10 meter per second, which is the difference between the velocity of balloon and the boat. Similarly, if a person on the boat watches the person on balloon, again it will find that the velocity of balloon is only 10 meter per second because the body itself is moving with 10 meter per second. So that is the concept of relative velocity. So after covering all those topics related to the motion in the straight line, I hope everything is now clear to you. So watch this video very carefully because it will help you a lot. So thank you students, thank you so much. We will definitely meet in this next video to understand the concept of the physics. Thank you so much.